Before we dive into the complicated one, we're gonna start with this simple one. To have the basics, we're gonna first design this one. This one is a simple rectifier, full wave rectifier circuit board. Yeah, we're gonna have it designed this way. As you see, behind we have the connection, and in front we have the components. As you can see, that's what we are going to try to come up with. What's this? Actually, electric PCB design. Let's go. As there are very many softwares used for advanced ones for PCB design, I have Altium design, I have KiCad, I have MIM. Today I'm going to use this one, Proteus 8 Professional, just because it has the other simulation element in it. Helps me to learn the behavior of my circuits before printing out the circuit board. Thank you. So we're gonna have here, we're gonna start with a schematic. In PCB designing, we have what we call schematics, and schematics works as the circuit diagram for your project. And when you are designing a PCB, is not the designing the circuit, but you're just designing that board, that where you are going to place your components. But the board already gives you those components. When the connection is already done, you just pick and place the components and have your project, your gadget, your device done. So this is the schematic view, or where we draw our wiring circuits, where we do the simulation and whatever. But for today, we're gonna have this basic. So how do we add the components in our schematics? Yeah, we have here the PIC device panel. It has a various devices. When you're well versed with electronics, you have various electronic components. Yeah, so I'm going to start. We are going to have connectors. As you saw, a PCB has a connector. I'm going to have here a pitch. Wrong spelling. I'm going to have here a pitch header block. Yeah, I'm going to choose the one of 2-pin. Yeah, I'm going to choose the one of 2-pin. Now here, when you select a component, friends, we have here, it says no simulation model. A header or a pin or a terminal block has no simulation mechanism. So every device that you choose on, in case you want to go into simulation, and I've indicated no simulation model, if it is like a power source or a bulb or whatsoever, inside it happens as if it is working, but your eyes will not see because it has no simulation model. So terminal blocks have no simulation. Another thing is we have here PCB preview. This is the schematic symbol, and this is the PCB preview. And note that whatever component you pick, it is going to have a PCB preview now. So when you're aiming at PCB design, make sure your device, your component that you have chosen, it has a PCB preview, or it is called a footprint. If it doesn't have, you're going to go to your PCB, but the software will not be able to show your components there. Wow, so it has to be having both the schematic symbol as you see it here and the PCB preview. So I'm going to choose that one. I'm gonna say okay. I'm going to add another gadget. Remember, I just want to try this out with a simple rectification circuit, and we are going to do a full wave rectifier. So I will need here this one, N4007, that yeah, just gonna go. As you see, my diode, it has a schematic symbol, then it has a footprint or a PCB preview. That one is going to work for me. It's going to be viewed. Then we have, what else? You're gonna have something like a capacitor. I'm gonna use this coupled capacitor. Yeah, you choose, it has the symbol, it has the footprint or the preview. Yeah, those are the main components I'm gonna use for now, just the basic to show you how the thing is done, but in the future I shall see how to come up with some complex stuff. Yeah, so I'm gonna have my terminal. So here to place the components, make sure that you are here under component mode. You select your cursor under component mode, then you select here the component you want to place. Then when you move into the schematic draw window, it has to show something like a pen. That means it's going to put your what, your symbol. So just gonna zoom in a bit. Very good. I'm gonna rotate this one, something like that. Then I'm going to have my diode. That's diode 1. I'm gonna rotate something like that. That's diode 2. I'm gonna rotate it like that. That's diode 3. I'm also gonna rotate, or gonna rotate it like that. And this is diode 4. I'm gonna rotate it anti-clockwise like that. So that is, we have placed our diodes. Let me move it a bit down here. Yeah, let me move my pin header a bit. So I'm gonna name this one, yeah, part value, just gonna say input. No, cancel that one. I'm gonna name this J1 into input. Yeah, this one D1, D2, D3, D4, just gonna leave them like that. So I'm gonna have my couple capacitor. I'm gonna put it around here. Remember, the main essence of this one is not to teach you how a rectifier is or how to come up with a rectifier, but the main essence is how to come up with a PCB, though you may get both at once. So what we are going to do, I'm gonna rotate my capacitor like that. So I'm remaining with some. We are going to put also output, by the way. Yeah, just gonna rotate this one to 180. Oh no, I'm going to leave it the direction it was. Yeah, just gonna name it output. So we all know bridge, full wave bridge rectifier, we need something like 4 diodes. This is when you have decided to use one diode by one, though we have a rectifier ICs. So we need to put the methane capacitor. So what you'll have to do is, on the input side, put your AC voltage, then you expect your DC voltage in the output side. What else are we going to do? You are going to do the connection. So we are going to move a cable. Connection is so easy. Just move your wire. When the cursor is showing the pen symbol, only what you have to do is to tap the tip of the device and you move your wire just like that, corner per corner, like that. So you shall have to link these ones. So that is the bridge connected. Now what we have to do is to get the outputs. So this is the positive, it's going to go to the capacitor, and this is the negative, it's going to go to the capacitor. Then after being smoothened, of course, we are going to give it our load. Boom, schematic is done. Any question, please don't hesitate to post it in the comments below. If you don't know what a rectifier circuit is, please, we can work out on that one also. Though for today, it's just a basic to see how to go about with this, but more work is coming, So our schematic is done. Actually, all what we need to do, please, people, don't always forget to save your project. You're going to lose your work. Now schematic capture is done. What is next is we are going to go to something here called PCB layout. So when you click PCB layout, it's there. You see we have all the components we used. They are here in the list. What do we have to do? We have to drag and drop them in the PCB panel. So I'm going to start with the input. Come here, select component mode. As long as the pen appears, you're free to click and place your device. I started with the capacitor. Just gonna do some Ctrl Z and do previous action, the schematic. Okay. I've done on the schematic, but it's easy. This one you can just place back. Okay, save project, come to PCB layout. So we shall start with the output, input. We shall place the input. Then we shall have that one, just the way we arranged in our schematic. That's how we are going to arrange in the PCB. We have diode 2, we have diode 3. Now let me see how we have 1 2 3 4. Yeah, I'm gonna make this thing so simple. So just come here, cross out this, come here, cross out this. So I'm gonna have diode 2 somewhere here, I'm gonna have diode 3 somewhere here, I'm gonna have diode 4 somewhere there. So just gonna rotate this, something like that, and I'm gonna rotate this one, something like that. Gonna rotate this one, something like that. Let me check my schematic. Okay, console. This one I'm gonna rotate 180. I'm gonna rotate this one 180. So I'm gonna rotate this one like that. So I'm gonna rotate this one clockwise like that. So just gonna place them properly. So remember, the way you arrange here components, that's the way it's going to appear on the PCB. So remaining with the one I'm having here, capacitor. Yeah, so just gonna have clockwise rotation. Then I'm going to have the output, and I'm gonna make a clockwise rotation also. So that is it. Capacitor is a bit spaced. So here we take time because it is our final design. What you see is what you get. So after that one, we are going to choose here. Want to choose some color, solder side, component side. I'm going to choose square layout. I'm going to choose something like body edge. Then I'm going to draw the edge for my PCB. That one is not required. Come here to select. Just resize this one a bit. So now it is not complete. What we are remaining with, as you see, this connection is not all that, it is not final. So we are going to come here to technology, set layer stack up. So I'm going to have we are going to come technology, set layer pairs. We are going to have bottom copper, and as well as bottom copper we are aiming at using a single layer PCB. Oh, what is single layer, what is double layer, what is 6 layer? Yeah, shall see all that. Let's just have the simple preview of this one. Then we are going to come here, something like design role manager. I'm gonna have net cases, gonna have signal here, trace. I'm gonna have T30. I'm gonna have here T30, and that's thickness. Then where I'm going to have something like V40. Where type gonna have, so here don't forget bottom copper. I'm gonna have through hole. Yeah, think you can go with that one. Priority V30, what design role defaults, just say okay, let's try out that one and see. Then we come here to auto router, we see what happens. Fin out passes I'm gonna make 100. Wire grid, let me try to leave everything the way it is, and I see how it comes out. Then say begin routing. All value for fin out not range to 20. Sorry, this is just make 10. Begin routing. Yeah, now it has finished the routing. That means it has finished making fast connections. But this connection, you can change it. You can change the way you want if this does not shoot what you want. Oh, sorry, we forgot out something. Going to say Ctrl Z. We forgot out something. Let's check our schematic. This is not how we connect. This is not how we connect. So what we are going to do, come here to component. We are going to delete this one. We are going to delete this one. So how do we connect this one? We are going to have this one here and this one here. Sorry. Okay, we are going to save this one. Save project and come to PCB layout. Yeah, it has been updated. Thanks. Then we are going to come to auto routing now. Just say begin routing. Yep, so it's not all that the best. So in case the wires are not passing where you want, you can just adjust them. You click on it, you move. Though mine can say I'm well versed with whatever connection it is, though there is something missing. I think. So let me check it in 3D viewer. So we come here with select 3D viewer. That's how it's going to look. Wow, with the components. Now when I check back, one connection is not made. Are you seeing this set here? They are not connected. So what do? We go back and do the routing again. So PCB layout, you first check your schematic. It has to be there. This line was not put. So we are going to do the routing again. Auto routing, repeat phrases. I'm going to have 10 of them. And it's say begin routing. Wow, it's not making it. Okay, actually it made it. It has now made it, but it passed through this side like this. Check. Are you seeing? it is the same connection from here, like just connecting it directly here. So in case you're not contented with it, you can change. We shall see all that in the next. All this is just a sample. So this is how our PCB is going to look. We can remove the components. So after removing the components, because when you're printing the PCB, you can choose not to come with the component. That's the most done thing, and that's the cheapest thing. That's when you have your own components. You just need the board already connected. You place the components, solder, and boom, you keep on moving. Only what you need, the PCB to help you with the connections. So now just one more thing, I'm gonna put my brand here. Gonna have come here to text, add here text. Just wanna say here Bawashir. Yeah, I'm gonna have it center. I'm gonna have it not default font. Okay, can just have something like tens, Neo Roman, something usual. Can I have it bold and italic and say okay. Then I'm gonna have something else called electric. So yeah, one or more design rule, what problem? Let's have it like removed. I'm gonna put it here. So whenever you see that error, that means your board has a problem. You shall see how to deal with those errors. Say here right, just say right, say was okay. Now this error is that this word is not supposed to come on the routed cable, because during printing they are going to cut it out. You see? So this is copper, you put it in copper line. That means when during the printing, again the copper line is going to be distorted. So when you come here to 3D view, come here, file, can save your project. So it is unfortunately that I wrote it in the same board edge design, but okay. Our board is not updated, so we're gonna just have this one. Right click on this one, change layer, come to top select, select this one, change layer, come to top select. Yeah, so when you come to here, so that is partially electric. When you bring back our components, that's how your board is going to be when fully finalized, when fully finished. So what about this? So after the board, how do you do? After the board, we are going to come up with a Gerber file. A Gerber file is that file that you take to the person who prints these PCBs, the one you can use to print for your circuit board. What you have to do, come here at PCB layout, select output, then generate Gerber file or exclusion. Just say yes. Going to do multiple tests for your board, and say 0 errors, 0 failed, 0 warnings, and 13 passed. Wow, say okay. Then you say close this one. So this is whatever component your board has. This is whatever your board has. You have top copper, bottom copper, top select, top resist, you have bottom resist, you have. So if you feel to change, you can change this. You have some drills for the through holes and whatsoever. It's not so much better, but you can run Gerber viewer when done. Then you are going to output it as a single zip file. I've renamed my file. This is rectifier, just rectifier. Okay, I'd renamed it recorded, though it is not in line with what we are doing, but let me just leave it for you. Are going to name it the way you want. Then automatically open is don't open output folder. Okay, output to a single zip file. That's where you are going to make all your files into one zip, so that you can just send it to the printer and it prints out your board in case you have one. Then run Gerber viewer. Not necessary, you can run the viewer to check out what you have done. If it is okay, say okay. Yeah, as we wait, it is not this one, it is coming, it is still processing. Yeah, since we chose open file location, this is recorded. It is here. Recorded card comes zip. So this is the file that you send to people who are supposed to print. Right now I'm in Uganda, and our best printers here we have JLPCB. Just go select JLPCB, search on Google JLPCB. So you see JLPCB, PCB prototype, and PCB fabrication manufacturer. It's so far the common one here. So that's JLPCB. All what you need to do is create an account with them, upload your Gerber file, choose whatever, how many pieces you want. Then it's like an online order app. Then they are going to have your PCB printed. Then they are going to export or ship it to whatever location you are. Then you put there your components. They do up to 32 layers PCB, and they are very cheap. Wow. So back to our project. So after this, the Gerber view, our Gerber file is done being generated, and now we have the Gerber viewer. So at the end of the thing, we started coming up. We started with the schematic, that is the circuit. Then we put it to a PCB layout. Then we had the 3D version of it view. That's without the components. If you have here, put the components view. Then we have the Gerber viewer. So the Gerber viewer, that's the final thing, is going to show you how your thing is going to be, how it is going to come like. That is for the computer or the printer purpose and the manufacturer purpose. Your task is done. So what you're going to receive is something looking like that. See you when you see me. We're gonna do some complex PCB designs and electronic circuit simulations. Don't forget to subscribe, share, like, and comment with whatever you feel like we should adjust on. See you when you see me. Electric.